In this video we will discuss about refraction through a prism. So here you can see we considered a prism AQ, just a second, AQ and R. Okay, now this is the incident ray, and one thing you should remember that whenever we are drawing any ray diagram for optics, we must give arrow sign. Okay, so this is incident ray at point N, just a second, this is not N, okay, this is H, this is H. At point H we are drawing one normal, this one is the normal, this dotted line. Alright, now if this is the normal, this is the incident ray, which one is the angle of incidence? This is angle of incidence, which is I. Now this incident ray inside the prism, it will undergo refraction like this. So which one is the angle of refraction? This is the normal, the dotted line, and this is a refracted ray, so this R1 is the angle of refraction. Now this light ray will fall at this point, where again we have drawn one normal. This dotted line is the normal for surface AR. At this point, point B, again there will be refraction. Okay, that means the light ray, it will move from prism to air in this way, in this direction. Okay, this is called the emergent ray or emergent beam. So in this emergent ray, this is the normal, so this angle is called E, which is angle of emergence. Okay, and this angle, it is given a name, which is R2. This is R2. Now in this prism you will get two more angles. One is angle of prism, this vertex, in vertex the angle formed is angle of prism, suppose it is angle A, and another angle is there, angle of deviation. So angle of deviation means it is the angle formed by the extended incident ray. This is the incident ray, this is the extended incident ray, and the extended emergent ray. This is the emergent ray. If you extend this emergent ray, here it is forming an angle. This angle is angle of deviation, okay, given by delta. So these are the angles generally we are getting in this prism. Okay, now here we are establishing a relation between angle of deviation, angle of incidence, angle of emergence, and angle of prism. Okay, so for that we will take the geometrical process. So you have to see the geometry of the figure. First of all, we are starting with this triangle FHB. Where is the triangle? FHB. F, okay, HB. In this triangle, which one is the exterior angle? Delta is the exterior angle, and the other two interior angles, which one? Okay, delta is the exterior angle, interior angles are this angle and this angle. Alright, now if this angle is I, this angle is also I mean this angle, vertically opposite angles. And if this whole angle is I, but one part of this I is R, this part is how much? R. So what is the remaining angle? I minus R. Which one is I minus R? Which angle? Angle FHB. This angle is how much? I minus R1. R1 here it is. Okay, I hope it is clear. So this angle is how much? The whole angle. Since this is E, the whole angle is how much? Again E, vertically opposite angle. Now since if this is E and this part is R2, then what is this angle? Means FEH. How much is that? E minus R2. Okay, this angle is E minus R2, this angle is I minus R1, and delta is the exterior angle. So we know that exterior angle is equal to what? the sum of the other two interior angles. So that means exterior angle delta is equal to sum of the other two interior means this one and this one. So how much we got? I minus r1 plus e minus r2. So rearranging it, we get I plus e minus is taken common, we will get r1 plus r2. This is given equation number 1. Next triangle NDB. Okay, by mistake I have again written here N, but actually this will be HDB. Okay. We can do one thing. Since everywhere in place of H I have written N, better we consider it as N. Okay, and just you change this one. This H will be N, means the triangle will be FNB. Okay, FNB. I think it is clear now. Then no need to change anything. Just to change the name. This is suppose N. This is FNB. Okay. Then second one, triangle NDB. This one, the lower triangle. So in this lower triangle, we have three angles obviously, R1, R2, and angle D. Angle D is which one? Which angle is angle D? This angle. Okay. So summation of all these three angle is 180 degree. This is given equation number 2. Then we are taking a quadrilateral which is ANDB. ANDB, this quadrilateral. Now if you notice nicely, in this quadrilateral, this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. Why? Because already I told you this is the normal on this line. So this angle is how much then? 90 degree. Similarly, this is the normal on this surface. So this angle is also 90 degree. So in this quadrilateral, this angle and this angle is 90 degree. Rest two angles we don't know. So we will keep it as this angle as A and this angle as D. So A plus D plus the rest two angles. So rest two angles is how much? It is 90 degree. Just now I told. So here it is this one. Okay. So in this place we will write 90 plus 90 means how much? 180. And we know that summation of all the four angles in a quadrilateral is 360. So this 180, as we take it in right hand side, 360 minus 180 also gives us 180. So what we have, A plus D is equals to 180, and here what we have, R1 plus R2 plus D is 180. If you compare these two equations 2 and 3, what we are supposed to get? What is that? 180, 180 same, D same. That means what? R1 plus R2 is equal to A. So R1 plus R2 is equal to A. This is given equation number 4. Okay. Now, next step what we are going to do is we are going to substitute R1 plus R2 as A in equation 1. So what it will be? Delta is equal to I plus E minus A. So this is the relation. Okay, just a second. We have done it here. Yes, this one. Okay. Delta is equal to I plus E minus A. Alright. So this is one equation that you have to remember related to prism. Then certain things I will say here for thin prism. If the prism is a thin one, in that case these angles, angle I, angle R, these will be very small angles. And when the angles are very small, we can do it like this. Sin I can be written as I, sin R can be written as R, nearly equal. So from Snell's law, sin I by sin R equals to mu, we can write I by R equals to mu. Alright, and from this I is equals to mu R. So in the same way, okay, in the same way we can write like this also for prism. Just to remember the diagram of prism. In diagram of prism we had the refraction which has taken place twice, right? Once the refraction has taken place here, once the refraction has taken place here. So when the refraction is taking place here, what will be Snell's law? Sin I by sin R1 is equal to mu. When the refraction is taking place here, what it will be then? Angle of incidence is nothing but R2. So what shall we write? Sin R2 by sine E, then sine R2 by sine E, that will be equal to how much? Will it be mu? It will be 1 by mu, right? Because in the first case refraction was taking place from rarer to denser medium. In the second case the refraction is taking place from denser medium to rarer medium. Alright, so that is why the equations will be like this. For the first refraction the equation is this one, for the second refraction the equation is this one. I think it is clear. Then sine I can be replaced by I, sine R1 can be replaced by R1 for thin prism, so we get this kind of equation just like this. Okay, similarly for the second refraction, here to make it mu we are taking the reciprocal, so this will be sine E by sine R2. Okay, sine we are removing it, we are getting E by R2 equals to mu, so E equals to mu R2. Now we got I equals to this, E equals to this, for what? For for thin prism. And then from this equation what we can write, then delta equals to I plus E minus A. In place of I we can write mu R1, in place of E we can write mu R2 minus A. So it gives us mu, we are taking common R1. Okay, just a second, this will be R1, R1 plus R2, this will be R1 plus R2, so it gives us also A, so A we can take common, so we are getting delta equals to A mu minus 1. So this equation is applicable only for thin prisms. Okay, then another topic is there, that is angle of minimum deviation. Okay, there are many cases where we want this angle of deviation to be the minimum one, and under which condition we can make this angle of deviation minimum, that we will discuss. Condition. Okay, so we are starting with this equation. Here we are not talking about thin prism, normal prism. So we start with this equation. Here we can write I means, can we write root over I square? We can write same thing. E means, can we write root over E square? Same thing. This is the extra term that we have subtracted. At the same time this extra term we have added also, so the equation remains same. This minus a I have written it here. Alright, now next step, a square, this is like a square plus b square minus 2ab, we can make it a minus b whole square, and the rest two terms, that means this and a, will remain as it is. Okay, now see, delta has to be the minimum. We are finding the condition at which delta will be the minimum. So if delta has to be the minimum, out of these three terms, actually we want that all the three terms should become 0, isn't it? So that delta becomes minimum, minimum value means 0. But practically this is not possible. See, a cannot be 0 because it is a vertical angle, that means we call it angle of prism. Angle of prism cannot be 0, otherwise the prism will not exist only. I and E cannot be 0, obviously. I or E cannot be 0. Angle of incidence, angle of emergence cannot be 0. So these two terms are not going to be 0. So only option is that this term can be 0, and if it becomes 0, then delta will be the minimum. So delta has to be minimum, then this thing should be 0. And how this thing should be 0? Only and if I and E becomes equal. Okay, so root I minus root E should be 0, or I should be equal to E. So if both are equal, in that case only delta will be the minimum. Another thing, so this is one condition. What is the condition under which delta will be the minimum? That is I equals to E, and when delta becomes minimum, this angle we call it angle of minimum deviation. Normally, generally we say delta is the angle of deviation. When it reaches the minimum value, we call it angle of minimum deviation. Another thing, see, if this is one condition, another condition we can derive from this is that, okay, just from this two equation only we can say, I am taking this equation and this equation. See here, if I and E are equal, Certainly from the equation it is clear that R1 and R2 are equal. I think it is clear. This one, you just check this equation and this equation. One condition is that I should be equal to E, and if I and E are equal, then certainly R1 and R2 has to be equal, because right hand side is same, it is mu. So another condition is R1 should be equal to R2, which can be equal to any value R. So these are the two conditions, I equals to E and R1 equals to R2 equals to R. And another thing, very practical thing, if this happens in this case, if we simply observe the image of the or the diagram of the prism, we will understand that whether it is a minimum deviation condition or not. How we will understand that? Just a second. Okay. If delta becomes minimum, I said I and R will be I and E will be same. So this angle and this angle will be same. R1 and R2 will be same. If it is same, then remember this part of the light which is inside the prism, it becomes parallel to the base. Okay. If this line becomes parallel to base, then automatically I will be equal to E and R1 will be equal to R2. Okay, so I hope this part is clear. Then in next class we will find out the relation between mu, refractive index, angle of minimum deviation and angle of prism. Thank you.